EDX Decision 1, Algorithms, Sorting, Packing and Other Algorithms. An introduction to algorithms and flowcharts. Some key points on algorithms. An algorithm is a set of clear instructions. It must have a finite number of steps. It must work for any valid input. And it must have a termination or an end statement. You need to understand algorithms that can be written as text and flowcharts. For example, if you followed a recipe, that would be a simple example of an algorithm, or instructions for flat pack furniture, or if you've ever completed a lengthy application form, that can have a set of instructions that in effect would form an algorithm. Flowcharts can have different symbols used. For example, if you see an oval shape like this, where both ends are curved, that indicates a start or an end of the process or algorithm. A rectangular box contains an instruction that needs to be carried out, and a diamond shape box contains a question, and the route that you take depends on the answer to that question. So here is an algorithm represented as a flowchart, and just take a second to see if you can work out what this flowchart does. We can trace through the flowchart now. So what happens if A is 1, B is minus 2 and C is minus 8? And when you're tracing through a flowchart, it's a good idea to keep one finger if possible, or keep an eye on where you are in the flowchart so you don't lose track. So we start, and then the first instruction is input A, B, C. So they have been given. Then the next instruction is to calculate D. So D is B squared, which is minus 2 squared, minus 4 times A times C, which is 36. Then we have a question, is D greater than or equal to 0? And the answer is yes. So now we can have the next instruction, which is E. So we calculate E as minus B plus the square root of 36 all over 2 times 1, which gives me the answer 4. The next instruction is to calculate F. So F is minus B minus the square root of 36 over 2 times 1, which is minus 2. The next instruction is to output E and F. So E and F are the outputs of the algorithm. So the answer to this algorithm is 4 and minus 2. And then the next instruction is to end. And we can see now that this algorithm has found the two distinct real roots of the quadratic equation 1x squared minus 2x minus 8 equals 0. In the next example, what happens if we input A is 1, B is minus 2 and C is 5? So we've inputted the numbers, so the next instruction is to calculate D. So that's minus 2 squared minus 4 times 1 times 5. So D is minus 16. Then we have the question, is D greater than or equal to 0? And the answer is no. And then we go straight to the output, and the output is no real solutions. Notice we then follow this link, which takes us to the termination or the end of the flowchart. So we've just calculated there are no real solutions to the quadratic 1x squared minus 2x plus 5 equals 0. We're now going to look at a different flowchart, and we're going to produce what's called a trace table. And the idea behind the trace table is to complete each row of the trace table should correspond to each instruction or each line of the algorithm, or the flowchart in this case. So I'm going to input n, and I've chosen for n the value 2.8. So that's my choice. In the exam question you'll probably be given the input. So the next instruction is to set a equal to 1. The next instruction following the arrows is to make b equal to a squared, so that's b becomes 1 squared, which is 1. Then the next symbol is the diamond, so that's a question. Is a bigger than n? So is 1 bigger than 2.8? And the answer is no. So we now output b. So the output of b, so we output 1. Then we go to the next instruction, which is a becomes a plus 1. So although it looks like algebra, we need to read this as a, the new a becomes the old a plus 1. So a becomes 1 add 1, which is 2. Then we follow the arrows. B becomes a squared. So b becomes 4. Then we ask ourselves, is a bigger than n? Is 2 bigger than 2.8? And the answer is no again. So we output b, so we output 4. Then we go to the next instruction, which is that the value of a becomes the old a plus 1. So a becomes 3. Keep following the arrows. B becomes a squared. So 3 squared is 9, so b becomes 9. Is a bigger than n? So is 3 bigger than 2.8? And the answer is yes, 3 is bigger than 2.8. So we go to the final termination instruction, which is to end. So the output for this algorithm is 1 and 4. So this algorithm, this simple little algorithm, has squared the integers, the positive integers, smaller than 2.8. And exam questions may ask you to recognise what the algorithm has achieved. So you may come across algorithms that find prime numbers or square numbers or triangular numbers, etc. In the next session we'll be looking at bin packing algorithms.